evaluate the integral sine inverse of cos x. Let's begin with the solution, and we have integral of sine inverse of cos x with respect to x. So first let us assume that cos x is equal to t. On differentiating both sides with respect to x, we have minus sine x is equal to dt divided by dx, which implies that sine x into dx is equal to minus of dt. Now we know that sine square x plus cos square x is equal to 1. So from here, this further implies that sine x can be written as root over 1 minus cos square x into dx is equal to minus of dt. This implies that dx is equal to 1 divided by, now cos x we have supposed as t, so we have root over 1 minus t square into minus of dt, so we have dt with a negative sign. So this is the value of dx. So here integral of sine inverse cos x into dx can be written as sine inverse t into 1 divided by square root of 1 minus t square into dt, and taking minus outside the integral sign. Now again let us assume that sine inverse of t is equal to u, and on differentiating both sides with respect to t, we have 1 divided by square root of 1 minus t square into dt is equal to du. Therefore, this integral can further be written as minus of integral sine inverse t we have supposed as u, and dt divided by square root of 1 minus t square is du. So this is equal to minus of u raised to the power 1 plus 1 divided by 1 plus 1 plus the constant c. So this is equal to minus u square divided by 2 plus the constant c. This is equal to, now u we have supposed as sine inverse of t. So we have minus of sine inverse of t whole square divided by 2 plus the constant, and t in the beginning we have supposed as cos x. So this is further equal to minus of sine inverse of cos x whole square divided by 2 plus the constant. Now this is further equal to minus sine inverse of, now cos x can be written as sine of pi by 2 minus x. This is whole square divided by 2 plus the constant, and this is equal to minus of, now sine inverse of sine pi by 2 minus x is pi by 2 minus x whole square divided by 2 plus the constant. Now simplifying it further, this is further equal to minus of pi square divided by 4 minus 2 into pi by 2 into x, which gives minus pi x plus x square whole divided by 2 plus the constant. This is equal to minus pi square divided by 8 plus pi x divided by 2 minus x square divided by 2 plus the constant, and this is equal to minus x square divided by 2 plus pi x divided by 2 plus c minus pi square divided by 8. We have rearranged the terms and these two terms are constant, therefore taking them as C1, this can be written as minus x square divided by 2 plus pi x divided by 2 plus the constant C1. Therefore, integral of sine inverse of cos x into dx is equal to minus x square divided by 2 plus pi x divided by 2 plus the constant. This completes the solution.